All right, we saw how to solve exponential equations. We better look at logarithmic equations. And so logarithmic equations are just equations with logarithms in them to begin. Okay, so solving something like this, again, this one shouldn't take us much time to do because, again, we know the relationship between exponentials and logarithms. And so if a logarithm is isolated, just switch it to exponential, okay, via the circle method or the tattoo, aka the definition of a logarithm. And so this would be 3 to the power of 2 is equal to x minus 1 when we look at its exponential form. Okay, and so let's see, that's 9 is equal to x minus 1, and isolate x, 10 is equal to x. So we think that's the answer. The only thing we have to remember, and this is super, super important, and I'll say it about 5 times in this video at least, is that we need to check that we have a log of a positive number. So inside whatever it is, we want that value inside the logarithm to be positive, okay? So we actually do have to do the substitution back in. And so here, for our check, we would have log base 3 of 10 minus 1, and I don't necessarily care about the calculation, but I care that this 9 in here is a positive number. And that's because if we remember our logarithm, it had a particular domain, right? The domain of a log function was anything from, from 0 exclusive to infinity, right? So we have to make sure that once we find an answer for x from a logarithmic equation, that after substitution, we get a positive number inside the logarithm. Else, we violate the domain and bad things happen. Okay, so keep that in mind. So that's one archetype, is just using the basic definition of a logarithm to exponential function. Next one, we might see something where we have the same logarithm on each side and the logarithms are already isolated. Oh, this is a nice example. Because in that case, if we have a single log on each side and they're the same base logarithms, the injective property, kind of like what we did back here with this problem where we had same base exponentials, if we have same base logarithms, we can just drop them. And so we get something like x squared plus 1 is equal to 5. Okay, x squared is equal to 4. X is plus and minus 2. Remember, when you introduce a root or radical, you have to remember the plus and minus. And then if I wanted to check these, I would, so I want to do my check step. You don't need to show this work, but I think it is good to show. So we have natural log of, 2 squared plus 1. Yep, that's going to be fine. And then the other one is natural log of negative 2 all squared plus 1. That is going to give me a positive number. So again, that one's going to check. So I can report both answers. If one of them doesn't check, just leave it out. Okay. So that's another archetype for a problem that we could see. So then in general, right, if we look at solving this sort of equation, what are we going to do? We are first going to isolate the log, okay? So get rid of the 8, so I'd have, log base 4 of w plus 6 is equal to 3. Now, one thing that students might try over the course of working with logarithms is they see parentheses, and we're used to saying, oh, that number out in front can distribute, right? Actually, no. So the w plus 6 is inside of the logarithm, so we'd have to undo the logarithm before we actually distribute. So don't distribute with a logarithm. Okay, and we know our properties of logs too, so that 8 is actually an exponent on the inside. All right, moving on. So step 2, after we isolate the log, what are we going to do? We're going to do step 2 where we switch to exponential form, or just as we did with exponential equations and where we applied a log on both sides, you could exponentiate, that's a fun word, exponentiate both sides. It would have to be to the same exponent, so you could do like a base of 5 on each side, a base of 2, base of e, but you have to do it to both sides to maintain equality. Okay, so here I'm just going to switch it to exponential form. So 4 to the third is equal to that. So I'd have 4 to the third is equal to w plus 6. Okay, and then step 3 is going to be solve. Okay, so isolate w. So over here, continue my work, I'd have 4 to the third is 64. Yep, 64 is equal to w plus 6, subtract 6, we get 58 is equal to w. Okay, and then remember step 4, this is the one that we're going to forget and it's going to cost us points, but we need to check answers. Okay, and so what I want to do here is just go through and say, okay, I have 8 log base 4, and then I don't really care about the 8, but I care really about the 58 plus 8. And in here, I would just want to check that that's a positive number. If it is, I'm going to say it works. Okay, I don't need to go any further. That's it. Okay, so always check your answer. And so then I can finally report that my answer for this equation would be w is equal to 58. All right, so that's our general strategy. Now, some of them are going to look a little different. Some of them might not have a single log on both sides. And so remember that we have log properties too. That could be super helpful. So in that case, you want logarithms on the logarithms on the same side of the equation. Okay, so let's move the log base 7 of x to the right-hand side. So I'd have log base 7 of x minus 48, and then plus log base 7 of x. Oh, yeah, and then I have a sum of logs that goes, so sum to product, right? So I could actually say that this is log base 7 of a single product that is x minus 48 times x, and okay, so 2 is equal to log base 7, and then simplifying inside there, that's now x squared minus 48x. Okay, and now I have a single logarithm, right? So I went from 2 logs to 1 log. Oh, okay, so this is really fun. Then now switch it to exponential form. So I'm going to have 7 squared is equal to x squared minus 48x. Okay, so this is 49 is equal to x squared minus 48x. We could try factoring like an x here. That doesn't work because the left-hand side isn't 0, right? 0 product property, you have to have a product of 0 in order to use that. So, okay, well, let's make it 0. X squared minus 48, x minus 49. Okay, now that factors as x minus 49 and x plus 1. Okay, so then I get x is equal to 49 or x is equal to 1, negative 1, and I'm done, right? No. Remember, you're forgetting to check your answer, okay? So put both of these in, and I'm going to tell you that if you check them, the 49 will be just fine. The 49 will work because I'll get 49 in here and then I'll get 1 in there, and that's fine. It's a positive number, but the negative 1 is going to be problematic here because I'd have just log base 7 of negative 1, and that can't happen. So I cannot report negative 1 as an answer. Okay, so there we go. We'd have our only answer of 49 here, even though we also find an answer, an x value of negative 1 through the algebra. Okay, so I have it in big red letters there, but make sure to check your answers, and that'll and it applies for logarithmic equations only. Any equation where you start with a logarithm. Okay, so be aware of that and have fun with the algebra.